Anyway, motion in a straight line. So there's really not much here except for the fact that you guys need to work through a lot of questions.
Whoa.
Okay, because this is like not new stuff. We already did that back in unit 2. Okay, I will just remind you guys of the key concept. So when you get so the main 3 things are x, v, and a. What does x stand for, Charlie? In kinematics.
Even I know this.
I'll give you an easy one. What's v stand for?
Velocity.
Velocity.
X
Okay.
is position.
Yes, x is position.
Why am I writing here?
Okay, v velocity, a is for acceleration. Straightforward. Now, in order to get the quantity below, you get the top one and you derive it. Yes, to derive it. Now, if you want to get a turning point, okay, so some concepts at the turning point.
Why isn't x p?
Sorry?
Why isn't it p?
P for position?
Yeah.
Oh, good question. Now, the reason why x is position is because when you model position in a straight line, you normally draw a horizontal line. And you guys are more used to the x-axis as a horizontal line.
Yeah.
Not the p-axis.
Y equals X.
Does it make sense?
Yeah.
Yeah, so that's why they use x, because the straight line is normally modeled in a horizontal line. And in your Cartesian equation, the horizontal line is x. Okay, so that's the reason why x is for position. And then what happens at the turning point?
Is the velocity 0?
Yes, the velocity is equal to 0. It is turning at a certain point. At that point, velocity equals to 0. And then what happens at... Okay, actually no, I think we'll leave it there. That's mainly it. Okay, now what is the average velocity?
A rock.
Yes, that is the a-rock, so that's the average rate of change, which is the change in position over change in time.
So Y2 take...
It'll be
Wow.
x2 take x1 in this case, because x is for position. Yeah, but yes, that's the idea. It is y2 take y1 over x2 take x1, but in this case it will be change in time. So in this case it will be x2 take x1 over t2 minus t1, because it's the function is a function of time. So yeah, so lucky for you guys, you're not doing specialists, because they need to learn like acceleration as a function of position, or position as a function of acceleration and stuff like that. It's actually very interesting. No, it's actually interesting. Have you guys ever considered what happens when you drop a rock from a helicopter and at what speed it hits the ground?
No, I just know if you drop a coin from like the top of a building, it can like knock someone out.
It can't. They've done it before.
No, it doesn't actually knock someone out
It
because
doesn't
hurts
it doesn't
a
have
lot.
enough mass
It just hurts a lot.
to produce enough force.
Well, it just hurts
yeah,
a lot.
and because of air resistance, and you can calculate, because if you calculate it without using air resistance, the speed of someone dropping, let's say a thing from 1 kilometer, will be 500 kilometers an hour. That's like a bullet, right? But with air resistance, it's only 25 kilometers an hour. I'll just give you guys the end result. It's 25 kilometers an hour. That's actually one of the questions I did with
how much air resistance is? Are you saying...
No. So air resistance, the formula is 0.2 times v squared. So the faster your velocity, the more resistance, which makes sense.
Yeah.
Right? It's a square of velocity.
Force going... Newton's law, every force has an opposite and equal reaction.
Yeah. So that's why when you actually will learn that in specialist. Unfortunately, you guys won't learn that in specialist, but I just went through a question like that. It's really interesting.
Why does anything move then, if everything has an opposite and equal reaction?
Because so let's say you're pulling a box, right?
Of physics, come back here. So change in position over change in time is x2 minus x1 over t2 minus t1. And what is the average speed then? Blake, what's the average speed? Since you're good at physics.
Well, the average speed isn't it?
Yeah, I'm just bullying.
Total time over total displacement.
No.
Just total displacement, total time.
You use the wrong term. It's not total displacement, it's total distance. Displacement is change in position.
Oh, yeah.
So total displacement is actually average velocity. So total distance over total time. Okay? Over total time. Now what's the difference between like displacement or change in position versus total distance?
Distance is how far it's moved without considering the origin. Like displacement is like how far you've moved away from the origin.
Not from the origin,
Like,
from the initial position. It's different.
Yeah, that's what I mean. Like by the origin. Not
Doesn't velocity have?
Direction, yes.
Yeah.
So change in position, another word for that is displacement. So Sarah, if you're listening to this, you will have to learn about displacement in Unit 4 Specialist. But anyway, so change in position is displacement versus distance. Now, displacement is like this. If you have a particle, let's say it starts from here at 1 unit from the origin, and it goes to, let's say, 8, right? And then it turns back, go back to 6. So it starts from 1, goes to 8, turns around, and ends at 6. So the total displacement is the change in the position from start to end.
6.
So this is the total displacement, which is 5.
Doesn't it go to 6?
Yes, it's from 1 to 6, which is 5.
Oh, okay. I thought it was
Right?
0.
It's changed in position. This is the final x2, that is x1, right? So the displacement is displacement would be 5. Okay, but the total distance is not 5. The total distance traveled you need to consider, yes, the 1 to 8, which is 8, and then plus another from 8 to 6, which is 2. So the total distance
Is 1 to 8 7 though?
7. Yes, I made the same mistakes.
Yeah.
9.
Okay, yes, it will be 7 plus 2, which is 9. Alright, total distance would be 7 plus 2, which is 9. Okay, so watch out for questions where the particle does not start at the origin. Alright, you need to make sure when you calculate at the x at the turning point, you subtract the initial position, which may not be at the origin. Okay, and yeah, once you've got that, then you got the average speed, and I think that's about it. Let's try out an example. Let me go through this. Okay, example 30. How many examples are there? 2. Okay, so I'll go through 2 examples first, and then you guys can start working on the questions yourself. So since you guys are my A class, I will not give you guys hint at the question first. You gotta do it first, and then I'll slowly work through it. Okay, so I won't go through the questions first, but I'll go through the examples so you see some initial, like some idea, the ideas being put into place. So we've got the x equation. When I see these kind of things, I like to write xva on the side, circle x. I know I've got an x, and then most likely we need velocity and acceleration. Maybe
Derive.
no, you don't. Yep, just derive it. Find the initial velocity. So first you need to derive it. So v equals to, if you want to be fancy, you write dx over dt. Differentiate x with respect to t. dx over dt would be 2t minus 7. Okay, initial velocity is v of 0, which is 2 times 0 minus 7, which is negative 7. Put the units in centimeters per second. Okay. And then question B, when does its velocity equal 0 and what is its position at this time? What are they asking us to find here in question B? Can someone give me an intuition about this? Blake, I think we just went through this.
When does its velocity equal 0 and what's its position in time?
Yeah, what is this special position? Where velocity?
Turning.
Yes.
Turning point, correct. So question B is asking to find the turning point. Okay, so we're gonna try to think about why are they asking you to find these parts of the question here. The part B is just about find turning point. Okay, finding turning point, set velocity equals to 0. So you just get 0 equals to this thing, and then you just get t equals to 7 over 2. Okay, and then they ask for the position at this time. How do we find position?
You
Substitute it back into the original.
Yep, so it's x of 7 over 2. Okay, so that'll be 7 over 2, everything squared, minus 7 times 7 over 2 plus 6. So when I look at this equation, I'll try to see if I can take out any common factor, but this one I can't, so I just gotta work through it. So it'll be 49 over 4 minus 49 over 2 plus 6. Okay, have you guys seen the fast way of doing 49 over 4 minus 49 over 2? What is the answer? Can you guys think?
49 over 2. That's
No.
my guess.
negative 49 over 4. No.
Yes, negative 49 over 4 is correct. So this is what I do in my head, okay? If you can't, so Blake, have a look. If you see, when you see this one, you can do it in your head. You take out 49, right? So you take out 49 first, then you're doing 1/4 minus a half. Much easier. You don't need to deal with the 49, right? You just gotta times it back in later. Does it make sense?
Yeah.
And 1/4 is less than a half, it's exactly half of that, so that will be 2 over 4. and that'll be negative 1 over 4. So times it back in will be negative 49 over 4.
Quick maths.
Okay, so that's a little trick. You always take out common factors when you're dealing with like numbers. It'll be a bit easier to work with. Because most of the time when you do the multiplication, it's easier than you doing a subtraction. Right? Yeah, plus 6, now there's not much we can do. It's gotta change that into 24 over 4, and then you add that together. So we minus 49, that'll be 25, negative 25 over 4. Okay, and the unit is centimeters. So it's turning around at negative 29 over 4. Alright, so it's 29 over 4, which is roughly 6.25. Negative 6.25. Okay, actually I'll write that as a decimal. Negative 6.25 centimeters. Okay, so that is the position where it turned around. There's only one turning point. Okay, it doesn't turn around again at all. So then the average velocity for the first 4 seconds, question C, is just asking average velocity. It's simply asking x at 4 seconds minus x at 0 seconds over 4 seconds. Okay, and x of 4 you can just substitute it in. You can calculate on the side here. X of 4 would be 4 squared, 16, minus 4 times 7, 28, plus 6. So that'll be 22 minus 28 is negative 6. Alright, and then x of 0 is just 6. Alright, is everyone following?
Yes.
Yeah, which means when I sub it in to find average velocity, wait, Charlie, all good?
Yeah.
Yeah, so x4, which is negative 6 minus 0 over 4. So the average velocity is about negative 6 over 4, which is roughly negative 1.5 centimeters per second. So I'll give you guys an interpretation of what that means later, but we'll finish question D first. So question D is the average speed for the first 4 seconds. So the average speed would be the total distance over total time. But in order to do this, we need to draw something.
Wait, why did you do negative 6 take 0?
Because it's the final position minus the initial position. Alright, over final time, which is 4, minus the initial time. That's why you have to be very careful where the final position and the initial position
0
is.
counts as the initial position.
Yes.
Yeah.
Yeah, x of 0 is the initial position. Is an x at time 0. Right?
Wait, then why is it negative 6 minus 0 though?
Because the final position is negative 6. Okay. Have a look, pause, have a look. I will draw out the diagram. It makes more sense now. So if I were to draw it,
6 minus 6?
minus, wait. Oh. This time, Charlie, you're right. It is minus 6, yes. Why did I miss that one here? So sorry, it's negative 12 over 4, which is negative 3. Yes, Charlie, you're correct. Okay, anyway, so the initial position is 6, right? So 6, that's to the right of 0, and then the final position is negative 6. Okay, so what it's saying is that this is the initial position when t equals to 0, and this is the final position. Okay, so the average velocity is the change in position. Now we don't actually know how it got to the end. It's just that we know that it starts from 6. Okay, the total displacement is from 6 to negative 6, which is 12. Right, but it's not just 12. It's displaced 12 to the left. Does that make sense? That's an absolute displacement. Right? Displacement is just the absolute change in position. We don't know how it got there. Like for all that matter, the particle would have gone here and then did a bunch of turns around and do whatever it wants and then end up at here. It's still the same displacement. Okay, but so that's what displacement means. And now if we were to calculate part D, which is the average speed, you need the distance. So to do the distance, you actually need to draw out the travel graph. I call that the travel graph of the particle. Okay, so it started at 6, and then you gotta consider the turning point. So what's the turning point? It's negative 6.25, which is actually a little bit further away than negative 6. Right? So it actually went past negative 6, it turns around at negative 6.25, and then it ends at negative 6. Okay, so it starts at 6, goes to the left, goes past negative 6, and turns around at negative 6.25, and then it ends at negative 6, which means the total distance is
12 plus 2.5.
0.
Close. Not 2.5. It's too much.
Oh, 0.25. 0.25?
Yeah.
I said that.
Still
You
wrong.
said 2. Why?
Still wrong.
Negative. No. Because you don't do the signs.
12
Oh,
is
0.5.
yes, because 12 is this, 0.25 is this, but it turned around. So you're gonna add that another time. So that'll be plus another 0.25, which is then 12.5 centimeters. So the total distance is actually a little bit higher than normally. It's always higher, equal to or higher than the displacement, right? Because if there's any turning point, it will be higher. If not, it will be the same as the displacement. So in this case, the total distance is 12.5. So then the average speed, right? The average speed would be 12.5 over 4 seconds, which is 3.125 centimeters per second. Okay. Do you guys know why you need to know both velocity and speed? Even though normally you only care about speed when you're driving the car. You know why you need to worry about velocity?
Something important.
Okay, I'll give you a practical application. Did you know that at a quantum level, you can only predict, okay, based on top of my memory, you can only know exactly where the particle is or how fast it is traveling. You cannot know both at a quantum level. So basically, when you're studying atoms and stuff like that, you can calculate the velocity, but most of the time you can't actually determine the actual position of the thing at a certain time. You can only, if you know, at this time it's having this velocity, you have no idea where the particle is, where the atom is, or where the quantum, bits are. So, and if you want to know, take a snapshot, like, oh, at this time, the particles are in this position, you have no idea where it's going to go next. So, quantum physics is actually a very interesting field of physics where you have to deal with a lot of unknowns and you can't even see them. It's very abstract, but it's very interesting because those kind of physics is actually what makes a lot of technologies available, like your computers and stuff like that, your phone. Most of it is actually physics at a very, very micro level. So yeah, and at a lower level, if you care about velocity, you care about velocity because you want to know what direction it's going towards.
Yeah.
All right, you don't care about speed. No, speed is important, but velocity is more important. You want to know the sign. But in our everyday life, when you're driving your car, you don't care about velocity. You only know, make sure you don't exceed the speed limit, please.
Well, if you're reversing, do you have a negative velocity?
Relative to which point? You see, if you're relative to your line of sight, then you're correct. If it's relative to your line of sight, then when you're reversing, you have a negative velocity based on your line of sight. Not bad. Okay, that's a good idea.
I actually can't reverse in a car.
Are you serious?
It's hard reversing in a manual.
How?
Because it's like taking off in first. And I'm still improving at that. So it's like I'm going backwards and doing that. You're driving auto.
Okay.
You don't even know how to drive.
Oh, are you getting a manual license?
Yeah.
Cool. My license is auto. I used to learn manual, but I forgot how to use it. I vaguely know how to use it.
I'm just doing it because that's the car I'm getting. So.
Oh, okay. No choice.
And it's not any better, is it?
Well, it's more. I can drive Cody's car.
That's so cool. That's so cool.
All right, guys. Moving on. Example 31. Last example for this chapter. After that, you guys are on your own to do the questions.
You're just jealous.
All right. Example 31. A particle moves along a straight line. The position is given by that. Again, x, v, and a. We've got given x, so we might need to find velocity and acceleration by derivative. Question A. 1. Find the particle's greatest distance from O. How do we find that? Greatest distance from O. What kind of equation
2
is
pi. When t equals 2 pi.
Why?
Because that's the domain.
No.
The maximum domain.
Incorrect. What kind of equation is this?
It's
What's
it's a linear.
No. You know, I don't know what it's called. You know, you have logarithms and.
Yep, an exponential, and then what is this one called? That with t.
Trigonometric.
Yes, the trigonometric equation, right? So for trigonometric equations, or in other words, it's a forgot the other term, but basically it looks like that.
It's a sine.
Sine wave, okay? It's periodic, that's right, it's a periodic function. So it just repeats. So what you're saying earlier, Blake, is that, at 2 pi, it would be the highest. No, because 2 pi could be here.
Yeah.
It may not be the highest. So how do you find the highest?
The maximum.
Which is this one. How do you find what this point is?
Turning point.
Yes, it is a turning point. There are 2 turning points at the top and the bottom.
Derivatives for this?
You can, but you don't need to.
Yeah.
You can, but you don't need to. DS, remember, amplitude.
Well, actually...
So is the greatest distance just 3? No,
Not 3.
5.
Yes, it is 5. What's the least
5
distance?
Negative 5.
Not negative 5.
No. 5.
And negative 1.
Not negative 1.
Wouldn't it be... Because it's... Don't you add the...
1.
And 1. Correct.
Oh, yeah. That's right.
Now, the reason is this. If you study this function, right? So for question A, greatest and least distance. So let's say 3 plus 2 times sine 3t. So I'll write the sine 3t in blue. So note that sine 3t, this specific one, has a range of -1 to 1, right? When you calculate sine, it goes from -1 to 1. Okay? So the lowest value is -1, and the highest is when it's equals to 1. So let's say highest possible value of the function for x would be x equals to 3 plus 2 times by 1. And then the least distance, the least distance is when the sine part is equals to -1. So that would be x equals to 3 plus 2 times -1. And when 2 times -1 is -2, so 3 minus 2 is still 1. Okay, and then 3 plus 2 would be 5. So when you look at this, right, these two numbers, the reason why it makes sense is because, okay, what's the amplitude of this function? What's the amplitude of the sine function?
1 and 5.
No, the amplitude is not 1 and 5. The range is 1 and 5.
The amplitude is 2.
Yes, the amplitude is 2. The amplitude is how much it goes up and down. So you see on number line.
Because when you add 3 to it, 2 is your new origin value.
3 is your new origin.
3 is your new origin value.
And then you add 2.
Correct. So 3, you add the amplitude, you get the top one, you minus the amplitude, you get the bottom one. Right? The reason why it's shift by 3 is originally it's at 0. Right? So when you shift the whole thing up by 3, then it goes to 3 as the origin, as a new center.
How do you know what the least distance from O is?
The least distance is the lowest point.
But that's not the least distance, because it's still the same distance as 5 is from 3.
No. Yeah. So you see, this is the function, but this value is the x value. So this is the distance from O. So 1 means 1 meter from O, not from the center of the equation. It's from O. So O is the origin. So the particle on the x-axis, it looks something like this. So let's say this is 0, right? Originally, for like a x equals to sine t, so x equals to sine t, it would be
0.
Sorry?
0.
Yeah. So the center is also 0, and it only goes to 1 and -1. Right? So the particle actually looks like this. So Blake, have a look. This is actually how the particle will move in the sine function. Left, right, like that. Okay? But if you shift it, so first the amplitude is 2, means that now it goes to 2 and -2. So if it's 2 sine t, the particle is moving like this. Right? It's just oscillating between -2 and 2 horizontally. And then if you add the 3 to it, right, if you add the 3 to it, you're shifting the center of the movement to 3. So 4 and 5 will be like that. That means that the particle is oscillating around 3. Right? So it goes from 1, goes to 5, goes to 1, goes to 5. So the least distance from O is when it is 1.
Okay.
The greatest distance is when it's on the other side, which is equals to 5. Okay? Yeah, you can visualize that now? Yeah, so this visualization is really important to do trigonometric equations with kinematics. Because if you get it, it's really easy. Right? The answer to the first question is like, you can probably get 2 marks on this in the exam. And then find the times at which the particle is 5 meters from O. Okay, now this one is a little bit tricky. The times at which the particle is 5 meters from O, so x equals to 5, Then I sub that into the equation, 3 plus 2 sine 3t. And then subtract 3 divided by 2, so you get sine 3t equals to 1. How do we solve this? Charlie, you should know. Last week we did something similar, I think. How do we solve what time? At what time that sine of 3 times t will be equals to 1? Okay. First hint.
To change it into like, well, it's already in an exact value, I guess.
It's already an exact value, yes.
Like what it is at 1?
What do you mean?
Like what the thingy-majiggy is with the exact value of 1. So it's like sine and sine is on each side.
Yeah.
Is that sine of 2 pi is 1, right?
Not quite.
Or like sine of pi on 2?
Yes, pi on 2 is the first answer. But wait, remember this is a periodic function, so it will look something like that. So you want the value where sine equals to 1, which is going to be the top values, right? But how many answers are there?
Well, there would be, if it's for 2 pi, then there'll just be 1.
One answer. For a normal equation is one answer. But note that this is 0. Sorry?
2.
No.
4.
You're making guesses this one. Okay, no, I have a look.
Because if it's pi on 2, then there won't be another positive answer for it.
Correct. If this is
But
sine
you
1.
times it by 3.
Yes, you have to times the domain by 3. You're solving for 3t. So you need to find how many answers are there for 3t. This is the domain for t. That's not the same. So you got to times that by 3 in order to get the domain for 3t.
So is it 6t pi? Or is it just 6 pi?
6 pi. You times it by 3.
So then you'd have 3 answers.
3 answers, correct. So 6 pi means that there are 3 revolutions, and for each revolution there's only one answer, right? Sine equals to 1 is only the top point.
So
Okay.
So you have 3t equals pi on 2 to start with.
To start with, yes, it goes to pi on 2. And then to get the other ones, Blake, how do we get the other 2 solutions?
Why does it equal pi on 2?
Because on the sine graph, this coordinate here, right, this point here on the sine graph is 0, 1. So the coordinate on the sine axis is 1. So the angle is pi on 2. Because you always count the angle from the positive x-axis.
But where did the sine go?
Because it's the exact value.
No, I know.
Yeah.
I know.
Okay,
It's like
I think-
it's like what the angle is.
Correct.
Like what the pi thing is at when it is
When it
1.
equals to-
Yes, but because it's sine, if it was cos, then that would be 0.
Yeah,
Yep.
Like
no,
that,
I know that, but
Well,
Mhm.
that's what it is.
Okay. So I think I'll give my clarification for this. I think Charlie, you get it. I'll base it off Charlie's answer. Okay. What she said is that it's the angle, and that's correct. So this one, you see, sine equals 1.
Yeah,
This one, angle equals what?
at 3t,
So what
what
angle?
angle does sine equal 1?
Yeah.
Yeah.
So angle is represented by the point on the.
No,
on
no,
the
I
thing.
understand like the base angle and all that. I'm just like confused on where the sine went when you're writing it out.
Yeah. So I'm explaining that.
Okay.
Okay. I'm explaining like what happens to the sign, like the notation sign, right?
Mm.
So for example, let's say this is the unit. This is the unit circle here, right? This point, okay. This point represents 2 things. Okay. First, this point represents a coordinate of 0, 1. Make sense? But it also represents the angle of pi on 2. Right? Make sense? Yeah. But how do we relate these 2 information? Because the angle always comes from the positive x-axis, right? So how do we relate this? So the angle is pi on 2. And then the coordinate is actually equals to sine of the angle. Sine of pi on 2 and, sorry, cos first, cos of pi on 2 and sine of pi on 2. Does it make sense?
Yeah.
Yeah. So the coordinate gives you the sine and cos value. So I would write cos, right? Cos of pi on 2 is equals to 0. So if you have cos t equals to 0, then t must be pi on 2. Right?
Yeah.
Yeah. So that's what happened. It's like we're not getting rid of the sine. We're just more of like thinking along the line of, okay, what angle give you cos equals to 0? right? And the angle, as you find the point first, find out what angle the point represents, and then make sure that the coordinates correspond to the value that we're looking for. So in this case, we're saying, okay, sine at a certain angle is equals to 1. So what is the angle that gives sine equals to 1? Okay?
Pi over 2.
Same point. Pi over 2, yeah. And in this case, it's not t, it's 3t.
Yeah.
So that's why 3t starts with pi on 2.
Okay.
Yeah? And then how do we get the other two values? Charlie?
2 pi.
Sorry?
You add like 2 pi. So
Correct.
You
You-
have 5 pi and 2.
Yep.
9 pi and 2.
Yep, that's right. So you add 2 pi once and you add 2 pi twice, right? So it'll be 4 pi.
Yeah.
Okay, so that'll be pi on 2, so 3t will be pi on 2, that'll be 4 pi, so 5 pi on 2 and 9 pi on 2.
And then you divide them by 3.
Correct, you divide them by 3, so just multiply it by 1 over 3, so just change the bottom up, the top is the same, right? 5 pi, whoops, pi, 5 pi and 9 pi, and then the bottom just got to multiply by 3, so that'll be over 6.
Would you change the last one so it's 3 pi and 2?
Yes, you can change the last one to 3 pi on 2, 3 pi on 2. Yeah. Okay, so these are the times where the particle is 5 meters from or at the greatest distance from the origin.
Beautiful.
And then c is just velocity and acceleration. It's just derive it. Now c is the standard one. You guys have done this derivative of like many times. X equals to 3 plus 2 sine 3t. So then v would be deriving that. 6 cos 3t.
Wait, don't give it away yet.
Okay. Then I'll just write acceleration out.
Wait.
Wait, why is it 6 cos? Oh, no, yeah, I get it.
Do you get it, Blake?
And then do you leave and then the plus 3, does that leave?
Yeah, because when you derive a constant term, it's 0.
Okay.
How did it become negative in the A?
Charlie, why does it become negative?
For negative 8, because you're going.
Oh, because sine goes
Because you're
negative.
going back
Correct.
from cos to sine.
Correct. Well, you guys haven't learned trigonometric derivative at school yet, right? Just double checking.
What's this?
Like, you haven't learned how to derive sine and cos at school yet, right?
No.
Oh, okay. Yeah, I was like, wait. You seem confident, but I'm pretty sure you haven't learned that at school yet. You will learn that next term, I think.
D. Find the maximum speed and find the times.
Yeah, maximum speed and the times and location at which this occurs. So that will be question D here. Maximum speed. Blake, what are we doing here?
Find the maximum speed and find the top. Well, I don't know.
Would you put 0 into one of, like, 0 equals blah blah blah?
0 equals velocity.
Equals what?
Well, would it be?
Not velocity.
It would
T
have to
in
be
the velocity
acceleration.
equation.
Would it be acceleration?
It will be acceleration, yes. But wait. There is an easier way. So, okay. Maximum speed.
Wait,
How
which
come
question are we doing?
acceleration is the, like, maximum speed? Because I thought speed was the same as velocity, but just with
It is.
direction.
But
then how come we're using the acceleration one, which is the derivative of?
Of velocity,
Yeah.
right? Very good question. Okay. I'll pause this question. I'll give you guys a few more very important concepts. Okay. And I reserve it until this point and I'll mention it. So first, maximum speed. Speed is the magnitude of velocity. Okay. So speed is the magnitude of velocity. What does it mean by magnitude of velocity?
Velocity without direction.
Velocity without direction. So if the velocity equals to -2, that means the speed is just 2 meters per second, right?
Yeah.
Speed would be just simply 2 meters per second. We don't care about the sign. Now, maximum speed, all right? Maximum speed means even if you're going in this direction or this direction, it doesn't matter which direction, but what's the biggest number that you see, okay? So so that also means that when the velocity is increasing, right? Because let's imagine you in your car and in the dial, right? Your needle is here. When your velocity increases, it moves slowly to the right hand side in the car, right? And then at some point, if you stop accelerating, so you see a red light, you're like, I can't run this red light. Okay, you release your foot from the gas, then it will start going backward, right? The needle goes backward. When it's going backward, your speed is decreasing. Does that make sense?
Yeah.
Right? So it was increasing before, and then it starts to decrease. The point where it stopped and it stops increasing and starts to decrease, that's the maximum speed. And at that point, it's the instantaneous. That's when the gradient of the speed is 0.
Yeah.
Right? That's the turning point of the speed.
Yeah. So you do it like how I've done it before with like use altitude 0
into the acceleration.
Like more. But how come it's acceleration?
So, position, right? Let's say turning point of position is the velocity equals to 0.
Yeah.
Right? Because turning point of position is when velocity equals to 0.
Speed be like speed, you'd use the velocity one since it's the same thing just without.
Correct. So let's say maximum velocity. Let's say we change the question to maximum velocity, right? We do that first, and then speed is the speed.
Maximum velocity is the same as maximum speed.
Not the same.
Well, aren't they?
A little bit different.
Yeah.
So remember, speed is a magnitude of velocity. So I'll go through the difference later. But let's say let's say to avoid confusion, I change this one to velocity first.
Because you're trying to, because then you have to do the derivative of the velocity to find its turning point.
Correct, which is acceleration. Okay, so turning point of x is v equals to 0, and then turning point, right? Turning point of velocity. Okay, so turning point of velocity would mean acceleration equals to 0 because that's the rate of change of velocity.
Yeah.
Okay, now remember this is a periodic function, so it goes up and down like that. So look at the velocity equation. Yes, there'll be multiple points, but look. Velocity is a cost equation, right? And this one, if you were to sketch this, which you don't need to for question D, but if you were to sketch it, V against T will be a periodic function with an amplitude of 6, right? So it goes from 6 to -6, okay? And then it's a cost function. So it starts at the top, okay? Then it will go down, and then go up, and then go down, and then go up. Keeps on going.
The acceleration one starts at the bottom.
Not quite. So the wait. So
it starts at some, then it goes down first.
Yeah, it goes down first. Yes. But don't worry about the acceleration for now. So you see, this is the graph of velocity. So the maximum velocity will be these points, right? With the top points, right? These are the maximum velocity. But which points represent maximum speed? It's all of these.
Yeah.
So wouldn't it be
right?
12?
No, it will be 6.
12?
6 centimeters per second.
6 to -6.
No.
It's the turning points that show the maximum speed.
Yeah, it's just 6. So remember, this point represents the velocity is 6 meters per second at a certain time equals to, let's say, whatever value a here. Right? And at this point, oh no, I dropped it all out. Okay, at this point, this one means that at a time b, at time equals to b, a couple seconds later, the velocity is -6, but the speed is still 6.
Yeah.
Does it make sense? So maximum speed, so this is maximum velocity, it's just the top point, the maximum point, right? But maximum speed is both the maximum and the minimum velocity.
Yeah.
Right, like whichever is higher.
But then, so then when you're working this one out, you put 0 equals -18 sine of 3t?
Yes, you could do that, but what I'm saying is this is a periodic function, so you can deduce it a bit more easily. You don't need to go through that process. But normally you do go through set a equals to 0, and then you find turning point of velocity, which is going to be either a maximum or minimum
well,
of...
how would you do it if you were properly doing it?
Okay, so I'll show you two versions. The first version, using this graph here, since, right, velocity belongs to a range of -6 to 6, right? Because you can see that it goes from -6 to +6 because of the cost function, right? Since velocity is between -6 and 6, maximum speed, right? Max speed would simply be 6 centimeters per second. That's it, 2 lines. So the actual working for question D, the shortest way is just the 2 lines. That's it.
But you have to work out the times and locations.
Yes, you gotta work out the times and location. Oh, yeah.
I
Which is- So to find the times and locations, you will need to solve acceleration equals to 0. Yeah, so this is when you need to set to find the time. So
so you use the acceleration one to find the times, but then you can just like state what the max speed will be. Anyway.
Yeah.
Okay.
Yeah, because otherwise you will have to find the times and you sub back into the v in order to get the maximum speed, but we already know what it is.
So, it would be 0 equals negative sine of 3t. Or no, would you leave it? Would you divide 0 by negative 18? So
Correct. So just get 0 equals to sine of 3t.
So that's just 0 though, isn't it? Well, it could either be 0 or like pi.
Yep. But in this case, there are how many answers?
There would be.
Hint,
There'd be
this
6.
is tricky. It's not 6. That's the most obvious answer, but it's not 6.
3.
Not 3. 3 is way off.
Wouldn't there be?
6 is more close to it, but still, it's not 6.
Because isn't it like it'd be 0, 0, 0, 0, 0, 0.
Yeah. Now consider this. In one cycle, how many answers are there? Let's say if it's from 0 to 2 pi.
There's 2.
Not 2.
Isn't it 2 though? When like sine is.
It's not 2.
0.
Let's just say 0 less than equals to t less than equals to 2 pi, right? Let's say we consider one cycle.
It's 8.
And sorry?
Is it 8?
You mean like the final answer, not 8?
No, like are there 8 answers?
Not final answer is not 8.
Because
Not 8 answers.
sine of something equals 0.
0 means the 2 points. So Charlie, you're correct. It is the 2 points, but the first point represents 0. The second point represents pi. But
Yeah.
then the first point also represents 2 pi. So there are 3 answers. This is the only case in trigonometry where there are 3 answers in one cycle.
Yeah.
The only case. Okay.
Oh, okay. So then,
Normally it's 1 or 2.
but then, so would it be 7?
It'd be 9.
It will be 7, yes.
Why wouldn't it be 7?
Because in the next one, it's not like 1, 2, 1, 2, 1, 2. It's starting off with like 3, but then you're adding the next one. You're doing like 2.
Only 2 more.
There's only 2 in the other 2
Yeah.
cycles because
Mhm.
2 pi's in that one.
Mm-hmm.
So
It's like this idea here. It's like this idea here. Let's say we have a table, you sit 4 people, right? If you add 2 tables, you don't add another 4. You only add like 2 more, right? Because the original 4 is there, and then you only add 2 more, and the pattern only adds 2. It's like that. So every time you do another cycle, you don't add the initial 0. You just add 2 more. Yeah, and that's why it will be 3 and then 2 and 2, which is 7.
Yeah. And then you
Yeah.
divide them all by 3.
By 3, yes. So yeah, so the answer for 3t would be 0, pi, 2 pi, and just keep counting until you get 6 pi. Because every multiple of pi, sine of that will be 0.
Yeah.
Okay, so it goes from 1 pi to 6 pi, but also includes 0 pi, and that's the 7th answer. So that's why this is a tricky question where this is actually the only case, okay? The only scenario where there are 3 answers in the same cycle. There's no other scenario that will give you this result. Normally it's 2, right? Normally it's like top, bottom, or like basic stuff, but yeah, in this case, this is the only 3.
So
the only
those
time
are
you
your
get 3.
times when.
So that's when
speeds-
sine equals to 0.
Well, that's. Yeah, and so those are your times when you have your max speed of 6.
Yeah, that's right. And then the position you need to substitute these values in. Now, when you substitute these values in, there is something I want to mention here. Big brain move, okay? Big brain move is to not substitute the t value. So note that to find, okay, so these are the times. You need to find the position, sub t into the x, right? Which is x equals to 3 plus 2 sine 3t.
Okay.
Okay, so t into that. Now we don't substitute t because then you need to do the divide by 3 again. You substitute 3t. Does it make sense?
Oh, because that's the same thing.
It's the same thing. You just
Yeah.
substitute that straight into the sine function,
So,
and it will always be 0. Right? Because it will
so
be
then it's just plus 3.
yeah, it will always 3. Yeah, so x will always be 3.
Oh.
Okay, so the final conclusion is max speed is I think we found out was 6 centimeters per second, right? Occurring when say at t equals to 0, pi on 3, 2 pi on 3. Just repeating the answers here. 3 pi on 3 is 1 pi. 4 pi on 3, 5 pi on 3, and then 2 pi. Okay, and then always at x equals 3 centimeters to the right.
I don't get how you substituted in 3t.
Because
we've got the values of 3t here,
yeah.
right?
Yeah.
Algebraically, that's 3t, so we're substituting these values straight into here.
Yeah.
So you get sine 0, sine pi,
Because
sine 2 pi, sine 3
Because if
pi.
you put in the other, just the normal t, then you'll just be going back to the original anyway.
Yep.
Which is silly.
Alright, because if you sub t equals to, let's say, pi on 3, it will always cancel off, which is pi. And this is just the same as 3t, right? This one is 3t, the value here.
Yeah, but I don't. Why does it equal 3? I don't get it.
Oh, because, I see. And that is because this part will always be 0, right? Because the acceleration we solve for when sine of 3t equals to 0. So these are the solutions for 3t, where sine of that equals to 0. So when you substitute that back into here, the sine of that is 0. So this part is always 0 at these points.
I don't get it, but...
Okay. Even if we just to try one, right? If you are confused, just try a few. So let's say x of 0, the most straightforward one, right? Would be, let's say we'll go something a bit harder. X of pi on 3. That's when t equals to pi on 3, right? Which is that one there. Yeah. So then this would be 3 plus 2 sine of 3 times pi on 3, right?
Yeah.
And these 3 always cancels out, right? So that will be sine pi. Right? Sine pi is this point is 0.
Yeah.
Right?
Okay. Yeah.
And if you were to substitute the next one, which is 2 pi on 3, 2 pi on 3 and 3 times that, 3t, again, this one cancels out again. Right? And so you get sine of 2 pi. Sine 2 pi is this point, which is also 0.
Yeah.
And if you keep on repeating 3 pi on 3, 4 pi on 3, it's always at these 2 points, which will always be 0. So that's why the sine section will always be 0. And times by 2 will also cancel that out, so the answer is always 3.
Yeah, okay.
Okay? Yeah. Alright. We'll leave it that for now. So okay, try it. Just let him be for now. If he does enough questions, you still see the next part. You can't force it on people. If you see it, doesn't mean that everyone else will see it. Okay? But that's okay. If you do enough, Blake, it will come to you. Like what I said earlier, where when you substitute 3t in, right, it will be the same as sine 3t, which has always been 0 from the previous part. Does it make sense now?
Yeah, I think so.
Kind of, yeah. Good enough. Alright, so yeah, that's it. What is it? Describe the motion of the particle. Oh, yeah, well, I'll just read the answer off for you guys. The particle starts at x equals 3 and oscillates between x equals 5 and x equals 1 3 times. Yeah, I guess.
What's the maximum magnitude? Is that just the maximum magnitude of the acceleration? Is that what we just did?
Wait.
That's E.
Oh, I skipped E. Okay, yeah, you're right. That's right, there's still E. Okay, question E, find the maximum magnitude of the acceleration and then the times and locations at which this occurs. Same thing. Maximum magnitude of the acceleration. So this one, you just need to realize that you're talking about, okay, I'll start question E here. So the hard part in this chapter is not the it's not the main idea. The main idea is easy. You guys already know the motion, average velocity, and stuff like that. It's the algebra and applying the new equations.
Yeah.
ln, exponential, trigonometry.
Yeah.
That's the hard part because that's the new stuff in unit 3. Yeah, deriving sine cos e power x, and ln x. Those are the three new things in unit 3.
So how do we do E?
I'll apply that. Okay, so acceleration is negative 18 sine of 3t. Okay, the maximum magnitude is just 18.
Okay.
Now, does it make sense?
Yeah.
Yeah, because so you can conclude that therefore the maximum magnitude, is 18 because sine goes from negative 1 to 1. Right, and we talk about magnitude, so we don't care about the sign, so it'll just be 18
And we just
centimeters per second squared. Yeah, know that. And then find the times and location. So
we put 18 equals negative 18 sine.
okay, have a look. This one is the tricky part. It occurs when sine of 3t equals to negative 1 or sine of 3t equals to 1. Does that part make sense? This is the most important. This is the complex familiar part here.
Yes.
Does that make sense? Yeah? Because that's what we consider in order to get the maximum magnitude.
Yeah.
Right? So the maximum magnitude when the sine part is either 1 or negative 1, and you gotta solve them separately.
But how come?
Because each of them only gives you 1 point. Remember, when sine equals to negative 1, it's the point at the bottom.
Yeah.
And when sine equals to positive 1, it's the point at the top. So basically, when you combine these two, when you union them,
But how come it's negative 1 and 1?
because when this part
I understand
is
it being negative 1 because if you substitute an 18 into as like a, then you'd get negative 1. But then why? What about the positive one? Is that just because it doesn't have like?
it doesn't care about the sign,
Yeah.
right?
So
The
we have to
magnitude doesn't care
use
about the
both.
sign. You have to use both, yes. Yeah. Because based on this, remember I drew this little, did I have it? Where's that graph? Oh, here. See that little graph there? This is the velocity, and both the top and the bottom point, right, are when the velocity is, the magnitude is highest or the speed is highest,
Yeah.
right? Because if it's negative 6, the speed is still 6. That's still the highest speed. It's just in the opposite direction. Yeah, so you have to consider both the top and the bottom point.
So then you just find what negative 1 and 1 is. So that would
What
be
angle? Yeah, what angles give that? Yeah,
pi on 2 and 3 pi on 2.
correct. So now there will be again 6 answers, right?
Yeah.
Because we've got the domain is 0 less than equals to 3 pi less than equals to 6 pi. Sorry, 3t less than equals to 6 pi. So there will be 6 answers. This is a normal 6 answers one.
And then if you put those into the original, so would the location just be, it would be like negative 18 or positive 18 is when they would occur.
The position is no.
Or would you put it back all the way into the original one?
Yes.
So then it would just be, so would it either be, it'd be negative 2 plus 3 or 2 plus 3, right?
Say that again.
It'd
Will
be
be what?
negative 2 plus 3 or 2 plus 3, depending
Correct.
on if it's like pi on 2 or negative.
Yep. Or 3 pi on 2.
Yeah.
Yep. Correct. These are the kind of questions that most students will sweat when they see, what, 6 answers? I mean, I don't even know how to get one answer out of these. I've got that statement before. So if you actually understand it, pat yourself on the back. But that's not all. You gotta find the position. So Blake, does it make sense finding position? Just substitute the 3 pi in, or 3t in. Just remember we are getting this solution because we are solving this one here. So the answer will just be, the sine 3t will either be -1 or 1.
Okay.
Right? Because the main equation is sine of 3t. Right? So then I'll just be either -1 or 1. So x will be, right? It will be, the first one will be pi on 2, so that will be +1. So that'll be 3 plus 2 times +1, and then 3 minus 2, plus 2 times -1, and then it keeps on repeating, alternating.
Yeah.
Why did you do it? Why did we have to do it separately?
What do you mean do it separately?
Because you have to consider it as 2 separate conditions. So the first condition is when sine is -1, and that's the bottom part. Right? And then the second condition is when sine equals to +1.
But can't you get the 2 base angles, like that's alpha and that's 2 pi, pi plus alpha? And
No, this is not a base angle one, Black. The base angle is the, okay, so that's the symmetry, okay? The symmetry property, the symmetry property of a unit circle is when you use the base angle. That's when the angle is not the top or bottom or left or point.
No. I'd like.
So that's a different concept. That's an entirely different concept. This is the base angle, and then you got your alpha.
The same answer.
I wouldn't actually use the base angle in this case, because this is base angle is only used when the angle is like in the quadrant.
Okay.
But these angles are at the boundaries of the quadrant. Right? It's where the 2 quadrants connect. So it's not using the base angle at all. So it's actually just the 4 special points, top, bottom, left, right. Right, which is 1, 0, 0, 1, -1, 0, or 0, -1. So yeah, so then x would be 5 and 1 alternating. That's just a textbook answer. I don't think you will have something that has such a weird answer like this in the exam. Most likely they'll be like, oh, what's the position? What are the 2 positions that will cause this maximum acceleration? That's it. Yeah, and it should be like, oh yeah, 5 and 1. You don't need to mention the alternating part. I think that's just a bit weird to me. Okay, all right. So I think that's it. And then describe the motion of the particle. So if you've got the okay, just looking at the position, right? It goes from 1 to 5. It's just alternating between 1 and 5. And how many times it does that? 3 cycles. So it alternating between 1 and 5 3 times. And where does it start? When you sub x equals t equals to 0, it starts at sine 0, which is at 3. So yeah, so it starts at 3 and alternates from, it moves from 1 and 5 3 times. It alternates 3 times. Or oscillates, fancy word, oscillates between x equals 5 and x equals 1 3 times. Okay. Make sense?
Yeah.
Well, okay, all right. I think it's time for a short break, and then we'll do questions after the break, probably. Yeah, after the break.
All right.